Hi guys, I hope you're doing well. Of course, if you have any questions about anything from any of the lessons, please don't hesitate to ask. We can meet online through MS Teams, or you can just simply message me and I can respond with a written explanation of anything. So we're moving on to lesson 3. Today's lesson is all about taking what we talked about with correlation and investigating a bit further with that. Not necessarily in an analysis way mathematically, but just talking about how when you have a correlation between two variables, it doesn't necessarily mean that those two variables have some sort of link where one causes a change in the other. And this is the idea of what's called cause and effect. So if you look at these couple examples, it says sometimes we find a correlation between two variables, but that does not mean that one variable is producing the change in another variable. So for example, if you look at the first graph here where we have churches versus the crimes, there's a link here, obviously, with a pretty strong positive correlation, but it doesn't necessarily mean that more churches means that you're going to have more crimes. What it might represent is that, and if you think critically about this, is that there's some other variable that's causing an increase in both. And for this one, likely it's just the population increase. So a lot of people, especially in the media, they like to look for connections between two things and seeing if those things cause the other one. But just because you see a correlation, it doesn't mean that there is a causation or a cause and effect. The other example here is definitely a cause and effect, and this is the probability of a woman giving birth to a baby with trisomy 21, which is Down syndrome. And you can see as the age of a woman increases, so does the chance or probability of giving birth to someone with that. So this is what we would call a cause and effect relationship, where one variable causes a change in another variable. That another way of saying that is just causation. So in stats, we say correlation does not imply cause and effect or causation, as I've written here. So there are various types and degrees of causal relationships. So the first is just simply cause and effect, that there is a direct link between two things where we say a change in one variable, let's just say X, produces a direct change in another one, Y. So in math, you've often just said, okay, well, the change in one produces a change in another, but that's not always the case in the real world. So for example, these are things that are definitively defined. In science, that's often the case. Like here, the physics example, the higher a ball is dropped from, the higher the ball will bounce. That's a direct relationship. Or an increase in physical activity in biology, you know that you're going to cause an increase in heart rate. That's a physiological response that's guaranteed and therefore a cause and effect relationship. So if you look at these few examples, and we'll just talk about them, and if we were in class, I would just have you discuss them. Excuse me. The first one says a fish population in a lake versus the number of cottagers around the lake. Well, it's likely that as you get more cottages, so if I increase the cottages, it's going to decrease the number of fish. And so this is what we would call a cause and effect relationship. Second one says size of corn harvest and the size of an apple harvest. So you have to ask yourself, does the size of corn cause the size of apples to increase? Well, no, it's just simply a correlation. And again, in this case, there may be some possible common cause factor that's impacting both. And so likely it's just a good growing season. So for example, good weather. it's causing both the size of corn and apple to grow well. And the next one says hours spent practicing at a golf range versus the golf driving distance. And so most people who practice things are generally going to get better, but that's not 100% always the case for people, but so we would say it's a presumed cause and effect. It's not often that when you practice something that you actually get worse at it. And so we're assuming this is going to be cause and effect. So there are 4 other common forms of cause and effect that I'm just going to discuss. And so one I've mentioned already, which is the common cause factor. It's where you have an external variable that causes 2 other variables to change in the same way. So for example, the corn and apple harvest is changing in the same way, which is caused by some external variable. Another one might be as ice cream cone sales increase, so do drowning accidents. So they both are going up at a certain time, but there's an external variable that's common to both. So this is the common cause. So the external variable, again, might be just warm weather. Then there's things like the accidental relationship. And so you get a correlation that exists without any causal relationship between the variables. So 2 randomly things that might increase. And so things like you do well on tests when you wear a red shirt. And so this is an accidental relationship that happens. Or if you take any 2 connections that have nothing to do with each other, but they both happen to be changing. The next one I mentioned, which is presumed relationship, so a presumed cause and effect. So a correlation does not seem to be accidental, even though there's no necessarily proof of the cause and effect relationship, or that there's also not a common cause factor. So for example, let's say heart rates drop as fitness clubs bring in more revenue. And so it's presumed that maybe because they're bringing in more revenue, you've got more people working out, and therefore they're healthier, and therefore heart rate or heart attacks drop. And the next one, or the last one, is this idea of a reverse cause and effect relationship. This one's a bit trickier. This is where the dependent and independent variables are reversed. In the process of establishing causality. And so I put the example here where people who walk every day are happier people, but you could also do the reverse. So if you imagined it, you switch the people who walk every day and happier people. So you could say happier people walk every day. And so you could say one is causing the other, or reverse, the other one causes the first one. Another example would be the number of police officers, let's say, versus the number of crimes. So because there's more police officers, there's probably going to be more crimes identified, not necessarily that there is more crimes. And the reverse could be said, which is that if there are more crimes, it's likely there's going to be more police officers hired, and therefore they both increase each other. And so as one increases, so is the other. So what I'd like you to do, I would pause the video, and I want you to read through these examples and see if you can come up with, are these cause and effect? So you're basically classifying or identifying the type of relationship. Are they accidental? Are they presumed? Are they common cause? Or are they reverse cause and effect relationship? So if I were you, I would pause the video right now and then check your answers. So the first one here says the population of certain species of animals decreases as logging in wilderness areas increases. So this would definitely be a cause and effect because there's less habitat. Second one is the sales of sports cars increase as the school year comes to a close in June. This one you could kind of debate a little bit, but there's definitely not going to be a cause and effect, but it could be an accidental, or it's possible there is some sort of common cause, and that could be the warm weather. So you could argue that one. Next one says the price of bread and canola oil both increased sharply after the prairies experienced a common drought during the growing season. So this is an example of a common cause, which is the drought. And number 4, studies find that consumption of vitamin C reduces the number and severity of colds that people get. So because this says studies, we know that it's going to be a cause and effect. If it was just presumed, that would be different. So more vitamin C is reducing the number of colds. Next one says demand for consumer goods increases as the unemployment rate decreases. And so this one's a bit trickier because you could say as unemployment rate decreases, the demand for consumer goods also increases. So this is one of those ones where it's the reverse cause and effect. That's probably the hardest one to identify. Next one goes to a science one. Often these ones are just simply cause and effect, but let's check rate of chemical reaction increases with temperature. And so yes, cause and effect. And the last one says leadership ability has a positive correlation with academic achievement. Yeah, generally people who are good leaders do well at school, but not always the case. So this is kind of a presumed cause and effect. Okay, so hopefully you did okay on those. You can have a read through this. It's just an interesting little thing. It's on the handout and kind of sheds a bit more light onto causation versus correlation. And then you can try these questions in the textbook. And again, I'll be